Bismillahirrahmanirrahim. Dear students, welcome to the course of Artificial Intelligence. We are discussing lecture number 14, and the main topic of the lecture is learning types. This is your teacher Tariq Aziz, lecturer at Institute of IT, Kohat University, HANGU-CAMPUS. So let's move on to the agenda. Dear students, this is the slide where we left. So now we were discussing basically the instance space X, and then we discussed that in real life we will not always have the complete instance space X, but instead we will have some of the input samples which we denote by D and which we call the training data set. Basically, we are discussing the actual learning techniques for machine learning. And in the previous lecture, we discussed three of the techniques. The first one is rote learning. The second one is the inductive learning. The third one is the deductive learning. But we said that these are not the actual learning techniques which can be used for machine learning and algorithms. Instead, these can be used as components for machine learning algorithms. But in this lecture, we are discussing the actual learning techniques. So one of them is the symbol-based learning. We are discussing this. Now we left our previous lecture at this slide. So here now what we are doing actually, we are discussing the sample. Let me take you to the table here. We are discussing these instance space. So X is this complete column is known as the instance space, and the previous lecture we discussed that we will have 2 raised to the power 9 instance spaces. Okay, but it's not always possible in the real world that we will have all these instance space X, but instead now what we have the training data set which we denote by D, and we will have limited instance space. So this is the limited instance space. In this case we have x1, x2 and x3. If temperature is normal and blood pressure is normal, then the concept space is 6. Okay, but if the temperature is normal and the BP is normal, then the concept space is not 6, 0, and this is also 0 in this case. So what we mean to say that we will have the limited set of instance spaces like this. Okay, now we will denote this instance space with D, and which is known as the training set. So here again it says that we don't have any idea about the instances that lie outside this set D, because we choose some of the instances. Now the learner is to learn the true concept C based on only these three observations, so that once it has learned, it could classify the new patients as sick or healthy based on the input parameters. Now we have to use this instance space. Sorry, our learner has to use this instance space, and based on this instance space, our learner will then decide that whether the patient is sick or healthy. Now, dear students, the next thing is the hypothesis space. So, with respect to previous discussion, in almost all the real world problems where learning is to be done based on a few available examples, in this situation, the learner has to hypothesize. It would be insensible to exhaustively search over the entire concept space, since there are 2 raised to the power 9 concepts. This is just a toy problem, but if we have larger attribute sets, then imagine the situation. So, dear students, in this case, we just have 2 raised to the power 9 concepts, and it is equal to 256. But it says here that this is just a toy problem. So, if we increase this 9, let's say 2 raised to the power 100, then imagine the instance space. So, what we are doing here, if we have a larger attribute set. In this case, we have only two attribute. One of them is the temperature and the other one is the blood pressure, BP. And with these two attributes, we have total of 2 raised to the power 9 concept. But if we have a larger attribute set, we have more than two attributes, then let's say if we have 2 raised to the power 100 concepts, then think about the situation. Then in this case, we cannot rely on the previous concept. In this case, what we want from our learner to use the some sort of hypothesis. Okay, so that's why in this case, if this is the in look at this point. So if we have a situation like this, okay, now it says that we will come across a situation like this as we discussed previously. That's why searching exhaustively will not be a feasible option. Indeed, in this case, a learner has to hypothesize. So this is known as the hypothesis space. If our learner perform the hypothesis, if our learner has to hypothesize, then this is known as the hypothesis space. So now, uh, here in this slide, again, it says that our learner has to apply some sort of hypothesis. Why? To reduce the concept space. Our intention is to reduce the concept space, because with 2 raised to the power 9 concept, we will have these much concepts. But we said that this is with respect to only two attributes. So if we have a larger number of attributes, then we will have more than that concept space. But now what we want a learner to do, we want our learner to hypothesize. For what purpose? To basically reduce the size of the concept space. And for this reason, our learner can maybe use some sort of searching technique or the language bias technique to reduce the concept space. Now, dear students, this reduced concept space is known as the hypothesis space. Now, we will look at the example, and by the help of this example, we will look at that how the concept space can be reduced. So, for example, the most common language bias is that the hypothesis space use the conjunctions of the attributes. So here we will have attributes, and we will use the conjunctions and of the attributes. So for example, we have H, and H is equal to temperature comma blood pressure. In this case, what H is used for? H is used to represent the hypothesis space. So H means hypothesis space, and two attributes are used here. One of them is the temperature and the other one is the blood pressure. Now if you look at the comma here, then what is this? We can say that this is the conjunction of attribute T and BP. Okay, so this complete statement, basically what is this? The conjunction of the attribute temperature and blood pressure. So this is the way of using the conjunction of attributes. Okay, now dear students, if we in English, how we will pronunciate this, if we want to uh, explain this notation in English, then how we will explain this? If temperature is equal to T and blood pressure is equal to BP, then hypothesis is equal to 1, else hypothesis is equal to 0. Now this is the way of us reading this whole statement. Now dear students, what we will do now, we will fill in these two blanks with some particular values of temperature and blood pressure. It would form the hypothesis. So for example, if T is equal to normal, the temperature is equal to normal, and blood pressure is equal to normal, then how we will write this notation? Then we will write this notation like this: H is equal to, now our temperature is normal, comma BP is normal. Okay, so what will be the tabular form? This is the tabular form. So this is the blood pressure, and we have three values of the blood pressure. Blood pressure could be high, normal, and low. And at this end, we have also three values. The temperature can also be high, normal, and low. But what we did, we used the notation like this: hypothesis is equal to normal comma normal. So this is the normal, okay, and this is the normal. Blood pressure is normal, and then temperature is normal. So this is the intersection point, and we have 1 here, okay. Now dear students, uh, if, by this we mean that the hypothesis is equal to 1. Now the second example is, if the hypothesis, if we write the statement like this: low comma low. In this case, now temperature is low and blood pressure is low. So here again the table, we have blood pressure here, we have temperature here. This is the temperature and this is the blood pressure. Now both of them are low, so this is the intersection point. Temperature, blood pressure is no, temperature is no. Now our hypothesis is 1, okay. So if we observe the C2 from our previous example, then we get the same table as we got here, okay. Let me go back to the previous slide, and we just look at this C2, okay. We just observed all of the 2 raised to the power 9 different outputs at this stage, okay. So in this case, our C2, this one, is equal to our tabular form, this one, okay. So we got our C2 from the possible outputs. Now dear students, this means that if the true concept of 6 that we wanted to learn was C2, then the hypothesis is this would have been the solution to our problem. So it means that this could be the solution to our problem. But there is still maybe you people wonder that why we used the separate conventions for the hypothesis and for the concepts. And this is the whole statement, this C2, like we looked at the diagram previously, a couple of minutes before. We just looked at C2. So now C2 is equal to this, and then is equal to this is equal to the hypothesis. So here it says that you may wonder that then if this is the case, then why we have the separate conventions for hypothesis and the concept. So what's the reason? The reason is, or the advantage is that now we are not required to look at 2 raised to the power 9 different concepts. Instead, we are only going to have to look at the maximum of 17 hypotheses before reaching at the concept. So this is the reason. This is the a reason for this statement, that why we have separate conventions for hypothesis and the concepts. And the reason is that in now in this case we will have a maximum of 17 different hypotheses instead of 2 raised to the power 9 different concepts. So what we did here, we reduced the concept space by using the hypothesis, okay. Now we will look at this example, that how our hypothesis is reduced to 17 outputs. So we said that H is equal to T comma BP. Now temperature and blood pressure here can take three values: normal, high, and low. Low, normal, high. Okay, we know this. But now there can be two more values. One of them is the question mark, and the other one is the theta. So how much total values we will have? We will have five values. Okay, one, 2, 3, then 4 and 5. So total we will have 5 values. Now what is the meaning of the question mark? The question mark means that for any value h is equal to 1, while theta means that there will be no value for which h will be 1. Okay. Now what we are trying to do, we are trying to learn that how our concept space is reduced to 17. So here we have two attributes, the temperature and the blood pressure, and with each one of them, three values are associated: normal, low, normal, and high. But now we said that there are two more values. One of them is the question mark, and the other one is the theta. And question mark means that h is equal to 1, while the theta means that there will be no value for which h will be 1. Okay. Now, dear students, for example, if h1 is equal to question mark comma question mark, then it means that for any value of temperature or blood pressure, the person is sick. But if we take h2 is equal to question mark comma normal, then it means that for any value of temperature and for blood pressure is equal to normal, the person is sick. So this is the first example. This is our h1. Okay, this table is our h1. Blood pressure, three values. Blood pressure can be high, normal, low. Then we have the temperature can also be high, normal, and low. So now here both of them is the question mark, which means that for any value of temperature or blood pressure, the person is sick. So all of the values are 1. But with respect to the second table H2, it says that if we take the blood pressure normal, then look at the value of the blood pressure. It is 1 because we took this value now. Okay, the rest of the values are 0, 0. So the person is sick. Now, dear students, if we take H3 theta comma theta, then it means that for no value of temperature and blood pressure, the person is sick. So all of the values will be 0 and 0. This is our H3. Now, dear students, okay, we said all this. But how does this still reduce the hypothesis space to 17? So, well, it's very simple. Now the attribute T and BP can take 5 values, and we discussed these 5 values: 1, 1, 2, 3, 4, and 5. So 5 multiplied by 5 is equal to 25 total hypothesis possible. But if we just calculate 2 raised to the power 9 total hypothesis, then it become 512. Dear students, sorry, I made a mistake. Some of the I just 2 raised to the power 9 is equal to 512, but most of the time I just said 256. So it is not 256, but it is 512. Please correct this point. Now, uh, if we take this example 2 raised to the power 9, then the total hypothesis will be 512. But in this case, 5 multiplied by 5, we have total hypothesis of 25. So there is a big difference, and our hypothesis space is reduced to 25. But we are still left with the question of 17. How our hypothesis will become 17? So now, dear students, if we want to represent h4 like this, theta comma l, it would be the same as h3. Okay, so h3, if we represent h4 like this, then it will be same as h3, meaning that there are some redundancies within the 25 hypothesis. And these redundancies are due to what? These redundancies are due to this theta. So if there is this theta in the temperature or in the blood pressure or in both of them, then we will have same hypothesis H3 as the outcome, means all zeros. Okay, so dear students, if you look at the H3, this is our H3, and here we have all the values zeros. Now, if we take this H4 like this, so if we represent H4, or if we take this value as an H4, it says that it will be same as H3, meaning that the result of H3 will be equal to the result of H4, all zeros. So it means that we have some redundancies in our 25 hypothesis, and these redundancies is because of this theta. Okay, now dear students, if we want to calculate the number of semantically distinct hypotheses, then we need one hypothesis which outputs all zeros. Since it's a distinct hypothesis than others, so that's one. Okay, so we got all zeros. Here in this slide, it says that we want semantically distinct hypothesis. And a couple of minutes before, we just checked that one of the distinct hypotheses we got was all the zeros. Okay, so this is our distinct hypothesis, and here it says since it's a distinct hypothesis than others. Okay, uh, that's why this is one. And what about the rest? Okay, this is one. And how much left? 16 are left. Let me repeat the concept again, dear students. What we want semantically distinct hypothesis. So in this case, we got all zeros is in case of H3, and in case of H4, we got all zeros. So this is our distinct hypothesis. So this is one, and we are left with 16 now. Okay, so what is the rest of the combinations then? This primarily means that temperature and blood pressure can now take four values instead of five. Why? Because we eliminated the theta. Why? Because we said that redundancies caused by theta, and we want a distinct hypothesis. So we got all zeros, and this is one of our distinct hypothesis because of this theta. Because of this theta, we got some redundancies in our hypothesis, but we want distinct hypothesis, and one of them is the all zeros. So we got this. That's why we eliminate theta from our set. Now we will left with only four values, which is normal, low, normal, high, and question mark. Now if you multiply 4 multiply by 4, then you will have 16 different hypotheses possible. So this one distinct hypothesis of all zeros plus 16, we got the 17 which we talked about. So now our total distinct hypothesis is 17. So dear students, this is the case that how our concept space can be reduced to 17. Now this at this stage, I hope that you people will understand, but it says that it's a wonderful idea, but there is a cost. Okay, so what if the true concept doesn't lie in the conjunctive hypothesis space? What we want to do, we want our learner to find the true concept. But if this true concept doesn't lie in the conjunctive hypothesis space, then it will be a problem, and it says that this is often the case. So what we will do then, we will try a different hypothesis then, and if we have some prior knowledge about the problem, then it will always help. So dear students, I hope that you people will understand enough for today's lecture. Some other things regarding the symbol based learning, and we will discuss these things in the next lecture. Thank you.